In this video, we're going to look at how we would write the equation of a line in slope-intercept form. If 1, we're given the slope and the y-intercept. If 2, we have a graph of the line. If 3, we have points, 2 points on the line. So if you recall that our slope-intercept form is simply y is equal to mx plus b. And when we're given the slope and the y-intercept, we just put the pieces together. In this case, we get y is equal to negative 3x plus 1/2, and that's all there is. In the second example, in letter B, we have a slope of 0. So we might write y is equal to 0x plus negative 2, but 0x is still 0. And we could simply write this equation as y is equal to negative 2. That would be the simplest form. It is a horizontal line. A horizontal line has a slope of 0, and every line that has a slope of 0 is a horizontal line. We'll go down to the bottom. Y is equal to 7x plus 2. Just putting the pieces in for m and for b. Y is equal to 1/3 x minus 1. So those are some examples. When we're given the slope and the y-intercept, we just put the pieces together into our equation and we're done. So let's go on next to look at how we would write equations if we had a graph to work with. So as always, when I have a graph with points, I'm first going to label my points from left to right. x1, y1, I already made a mistake. x1, y1, x2, y2. Then I'm going to calculate the slope. M is equal to y2 minus y1 over x2 minus x1 is equal to 3. That's y2 minus y1, which is negative 3, over x2, which is 4, minus x1, which is 0, and we end up with 6 over 4, which simplifies to 3 over 2. Now we can just really check quickly, we should check quickly to make sure that the line has a positive slope, and it does. It goes up from left to right, and our slope is 3/2, which makes sense there. If you look at where the graph crosses the y-axis, it crosses at y is equal to negative 3, and so we put the pieces together. Y is equal to 3 over 2x minus 3, and so that's our equation of that. That's the equation of that line. Another graph. We're going to label from left to right x1, y1, x2, y2. Set up our slope formula. M is equal to y2 minus y1 over x2 minus x1. y2 is negative 1 minus y1, which is 2. x2 is 4 minus x1, which is 0. And we end up with negative 3 over 4. We can check quickly to see that our line is in fact descending, going down from left to right. And if you wanted to, you could even count here. Down 3, right 4. So that's a slope of negative 3/4. The y-intercept, we can see there, is 2. That's the y-coordinate of the point where the graph crosses the y-axis. You could also say that's the y-coordinate of the point whose x-coordinate is 0. We're ready to put the pieces together. Y is equal to negative 3 over 4 x plus 2. Great. Okay, we have one more of these to do, or a couple more of these. And so once again, x1, y1, x2, y2. Set up the slope formula. m is equal to y2 minus y1 over x2 minus x1 is equal to 3 minus 1. It's the y1 value. x2 is 4 minus x1 is 0. So we end up with 2 over 4, or a slope of 1/2. Y-intercept we can see is 1. Put the pieces together. Y equals 1/2 x plus 1. All right. Next, label the points. x1, y1, x2, y2. M is equal to y2 minus y1 over x2 minus x1. y2 is negative 3 minus y1, which is negative 1, over x2, which is 5 minus 0. And we end up with negative 3 plus 1 is negative 2 over 5. And we can see that we do indeed go down to right 5. And so our slope is, in fact, negative 2/5. The y-intercept is apparent from here. Well, you can't see it underneath my handwriting, so we'll clear some things out of the way. It is negative 1. Putting the pieces together, we get y is equal to negative 2 over 5x. Don't forget the x. And minus 1. And there we have it. All right, so we're going to look at one more type of situation where we're just given 2 points. We're not given the slope and the y-intercept. We're not told what they are. We're not given a graph where we can find those things. Instead, we're given 2 points, and we have to again calculate the slope, identify the y-intercept, and construct the equation. Alright, so let's see how that works. We have 2 points as usual from left to right. I'm going to label the 2 x1, y1, x2, y2. M is equal to y2 minus y1 over x2 minus x1 is equal to negative 1 minus 5 over x2, which is 0, minus negative 3, and we end up with negative 6 over positive 3, or a slope of negative 2. Now, we're not told what the y-intercept is, but you recall that the y-intercept is the point on the graph where the x-coordinate is 0. So b is equal to negative 1 in this case, and we write our formula. Y is equal to negative 2x minus 1, and we have an equation. Okay, we'll go on to the next one. x1, y1, x2, y2. M is equal to y2 minus y1 over x2 minus x1. In this case, y2 is negative 5 minus y1 is negative 5 over x2, which is 8, minus x1, which is 0, and we end up with negative 5 plus 5, which is 0 over 8, is equal to 0. Now, 0 slope tells me horizontal line, and notice all of my y coordinates are the same, so that would indicate a horizontal line. Horizontal line has the equation. Well, in this case we're shown. Notice that we have the y-intercept. That's the point where x is 0. So b is equal to negative 5 here, and that is the equation of the line. Y is equal to negative 5. All right, we're going to try that one more time here, and labeling our points: x1, y1, x2, y2, and m is equal to y2 minus y1 over x2 minus x1. y2 is 10 minus negative 2 over 4 minus 0, which gives us 12 over 4, or a slope of 3. The y-intercept, again, is the y-coordinate of the point whose x-coordinate is 0, b is equal to negative 2. Putting the pieces together, y is equal to 3x minus 2. That would be our equation, and we have seen how to write the equation of the line when we're told what the slope and the y-intercept are, when we have a graph of the line where we can identify the slope and the y-intercept, and when we have 2 points from which we can find the slope and the y-intercept. That'll be it for this video. We'll go on to see a couple more applications, or use equations of lines to solve some real-world problems.